Okay, let's get started. On last class period, we went over and, or, and not. No. Does anybody have any comments or concerns about that?
No.
Okay, so like I say, it's somewhat straightforward, but you got to remember and is inclusive, where both sides, or it's either, and not it just does the reverse. Okay, so let's look at menus. Okay, I think we've written programs dealing with modules. All right. And what I did, I created a program. I think I kind of went over it. I think I went over it with you all, might be the other class, with menus and showing you how you can create menus and using modules or either small code to actually execute that code when you need to. All right. So it tells us here you can use the use nested if else statements, or you could use the if else if. All right, where you actually check in if the, like say this would be a menu that would add a name, to remove a name, change a name, print a name, or quit that, anything of these options. So you would put up, normally have maybe option 1, 2, 3, 4, and 5. All right, and if you read through the chapter, it kind of goes through and show you here this program. But and we'll look at a program that I've written in online GDB. If I pull it up, I think I'm logged in already. Yeah, and if I pull up a menu, all right. So if I pull up menu, if we look at this program, starting from the beginning, I have a constant value of integer called quota. All right. Also in this, well, it wouldn't have quota that even, it's not even relevant, because what I'm doing, I'm allowing the person to input two numbers, and based upon what you do from the menu, we're gonna add the two numbers, subtract the two numbers, multiply the two numbers, or divide the two numbers. Okay. So here's our main program, where we have a value called choice. We need choice to allow us to make a decision as to what option we want to take. All right. And then look, enter choice, and then see in choice. So when we see in 1, 2, 3, or 4, then based on that value, we have our if logic down here that says if choice is equal to 1, then what? We performing something. Then we have a if else. Now we could have did else if. We could have did else it then but then and then put if inside of here and make it nested. But we just did else if. All right, else if this, and what that does, that nullifies everything here. So if this is true, all of this will be false. So that kind of helps in that using the else if. But then if we go through all of these choices, 1, 2, 3, 4, and 5, and none of them was the choice, then we will print out invalid choice. So what you're somewhat doing is trying to control the program from moving forward until a person actually inputs a valid choice. Right. So now we're dealing with validity. All right. Because you can put a comma, a dollar sign, it's going to be an invalid choice. Because we got choice as, let's see what we have choice. We got it as an int. Now we made it a char value, then it would put up somewhat work with dollar sign. But if we put a dollar sign in here, our program would somewhat bomb. It'll give us bad data. All right. So normally you would want to make if it's that single character, just make it a character or char value. But if you make it a char value and your list goes beyond 9 and you have 10, then it will not work. All right, you have to probably could use string or something like that. So looking at this program, this is my menu. All right, now everybody see this. It says system, open parentheses, close parentheses at the end, but inside double quotes it got clear. What that does is anytime the system hit this, or the computer execute this command, it's gonna clear my screen, all right? If you was on a Windows-based system like in Visual Studio, let me see, do I have anybody waiting? Yeah, okay, all right. So if we was on a Windows-based system, we would use CLS as the command because at the command prompt, CLS clears our screen, all right? And on a Linux or Unix system, clear clears the screen. I could give you an example of that here if I do CMD. All right, so if I do DIR give me a directory, right? It just shows me my folders and maybe files that I have. But if I do CLS, which I'm on a DOS system, so I just clears the screen up. And that's what that command will do. So, and I'll show you when we execute the program. So let's run this program, and then we'll still talk about the menus. So I'm running the program, all right, and what? It's prompting me to what? See in my first number. So I could put in 8, hit enter. It asking for the second number. We're right here in the program. And we put in 7. 8 and 7 is added is 15. 8 times 7, what? 56. 8 minus 7 is 1. What else? 8 divided by 7, depending on what I made it in or float, would be 1, 0.8, 0.9 something, right? So I type that in, but what's going to happen after that is going to clear my screen. So any information that I have on the screen, it's going to automatically wipe it out and then start my new CLs. So I have 7 here, and when I hit enter, see, I cleared the screen and wiped everything out. What happened? Oh, server. So let's run it again. Rerun it. 7, I'll put 7 and 6. All right, so here's the menu, all right? So we have our menu here, and now I can choose what I want to do with that menu, through that menu. I could type 1 to add the numbers, 2 to subtract, 3 to do whatever. But if you notice, if I choose 1, it says what? Add numbers. This is a function. It's calling this function. I could have added the statements in here, but I just created a function. It'll go down here to the add numbers function, and what? Total is equal to num1 plus num2. And then what? See how the sum of num1 plus num2 equals, and then total. If I would do a 2, it would do the subtract numbers function. And it would find the total. Total is equal to num1 minus num2. And then what? The difference of num1 minus num2 equals total. And the same thing for multiplication. 3, it'll multiply, and 4. Now, notice what happened with 4. Remember earlier we talked about a number being divided by 0. That's undefined. So we had to check to see if num2 actually exists. So we said if num2. And remember, when we do an if on num2, it will return true if num2 is positive, a positive 1 through infinitive, and a negative 1 through negative infinity. Anything other than 0 would make this if logic true, and it would perform this. And so what? If num1 is 5, it'll go ahead on and divide with whatever by 5. If num2 is -8, it'll divide this by -8. But if num2 was 0, it would make this false, and it would say what? Problem cannot be solved. No number is divisible by 0. Okay, so we can go back down here, and we can make a choice. Say we choose 1, all right? And what our result should be? 6, 7 plus 6, which should give us what? 13, right? So see what it says? Let me see if anybody else is okay. It says the sum of 7 plus 6 equals 13. All right. So that's how it will work. But let me run it again. I run it again. All right. And I'll put 7 and 6 again. And this time I'll say 3. I'll multiply. So that should give us what? 7 times 6 was what? 50, not 56. What is it? Let's see. Oh, 42. Okay. 7 times 7 is 49. All right. So the product of 7 times 6 is 42. All right. All right. So now, if I run it one more time, and now I'll put some numbers, 7, I'll say 6 again. I'll just keep it there. And number 5 says exit. I'll put a 5 in, and then it exits. Okay, it exits the program. It doesn't do anything. And watch if I put in 9 or 8, 7, 6. I can put any numbers there. Here, if I put in 8 as an option, see, invalid choice, right? But if I wanted to check for any single character, I would make this variable a char, okay? If I wanted to check for any string, any multiple characters for choice, I would make it a string, all right? If it was more than one number, sequence, like say 10 or 101 or whatever, okay? Any questions? And now, this was done with the if logic, okay? But now, what I do have, I have the case logic here, the switch logic. So what I can do, I could copy this logic here, right? And what I'll do, I'll copy it over the if logic, right? So it's the same program, and I'll just copy it over the if logic. I didn't copy out the comment, but I'm gonna copy it over this if logic. Paste. Now, let's look at the program. Now we had ifs, and remember we had those different levels. But with the switch kind of makes it a little bit better to understand, to some people. It's like you got choice, switch choice, trying to match whatever choice is. So this says, okay, grab choice. Whatever choice is, match it to see if it's 1. And match with the number 1. If it does, we perform in the function add numbers, and then we break it out of all this. So it breaks out of all this, and it ends the program. It checks to see if there's a match for 2. It performs subtract numbers. Then it breaks out of all that if it is, and then it ends the program. All right. So that's how it does it. It does it for each one. If it's neither one of these options, 1, 2, 3, 4, or 5, then you would get the default message invalid choice. So see, it's just like the if, like if else, if else, if else, if, until you get to the last one, and if it's default, you'll just output else, invalid choice. So it's basically the same logic, but written in a different way. So if we run the program, we'll get the exact same results, all right? So if I put in the numbers again, 7 and 6, all right? We have our menu here. And hopefully nobody's in this waiting room. All right. We have our menu here. And now I could type 2, all right? And hit enter. 7 minus 6 equal 1, and it exits. All right. So it does the exact same thing, but the logic is a little different. To some people, it's a little more simplistic because you don't have all those levels. All right. If it's 1, I'm gonna do this, but you can have other information in here. Like say other valid C++ statements. It doesn't matter. All right. So, and that's how you would create a menu. Now, and it would be a little tricky if I gave you a program, because what I could, from the previous programs, because what I could do, I could say, okay, write a program that will take maybe the first 3 programs you've written, all right, and create a menu system here where it might say programs completed in CSCI 1933. And then you would have 1, the name of the program, or either a brief description of what it does. 2, a brief description of what the second one does. 3, a brief description of what that one does. 4, exit, right? Now, depending on your choice, then what? You would have to have a module or a function in your program to go to and execute that code. All right. And notice we're not looking at, and when we looked at this program, we're not looking at passing values. All right. Because remember, we can what? Pass values. But what I did in this program, I made the variables global, meaning that they can be used in any function at any time. All right. But to make this program a little bit complex, all I would have to do is say, okay, I want the variables defined or declared inside of the main function. Then all of a sudden, you would have to, when you have this, you'd have to pass num1, num2. Now you wouldn't necessarily have to pass total because you can use total in the other function when you're calculating it, declare it, and then calculate the value, and then output it and then return. Okay, so then you'd have to pass those 2 values to each one of the functions that you need to use in this aspect. But in your program, depending on what variables you need to print out from the main, you would have to pass it. All right, I'll send from the main. All right, any questions? So everybody can understand menus. And creating menus, you just formatting your menu to look like you want it to look. I could have double spaced in between each one of these numbers or whatever, but it's all in how you make it look. And normally it's easier if you try to align your couts where, see, I got the double quotes and /T evenly. That way I ain't got to try to start here and try to figure out how many spaces and how many spaces or whatever. So it's like I got a grid from this point on, and I can see exactly how my output will look, space-wise, going horizontally. Okay? All right. So back to the book. So like I said, it just went through that program we just talked about. The validity part, we basically did that as we went through our if logic and even our case logic, so that what? It checked for each valid entry, and then at the end, we said what? Oh, invalid choice. So if we look at this example, what they're doing is they're doing something to calculate a student's grade based upon a score. So what happens is they made constant variables to equal to the valid value, which would be the minimum value of a grade. A score is a 90. That's the minimum they can make. B score is a 80. C score is a 70. D score is a 60. And then anything 0 or greater, which would be the 59 through the 0, would be a F. All right. So, but if somebody would put, and I'm just going to tell you what the program doing, if somebody would put like a -5, normally you don't make but a 0 on a test or better. So if they would put in a -5, it would check to see if test score is greater than or equal to 90. Oh, it's not. Else if it's greater than or equal to 70. 80. No, it's not. Else if greater than or equal to 70. No, it's not. Else if greater than or equal to 60. Oh, no, it's not. If it's greater than 0, what's that? Else, no, this. Else grade is F. All right. So if score was greater than this, okay, and let's see, greater than, where's that? Greater than or equal to D, do this. Else grade F. Something's wrong here. Because if it's not if it's not greater than or equal to 60, right, it could be a -5, it would do this. All right? Something is wrong with this code. Wow. Else, and this, oh, here we go. This is what they did. They checked the range. If it's greater than or equal to the score, min score, which is 0, and less than 100. So now what? Anytime it falls in here, we know the score is going to be from 0 to 100. But if it's anything else other than that, somebody waiting. Sorry about that. I'll turn my notification on. All right. So if they type it, what's up, Mr. Nunez? How long you was waiting? Oh, you didn't in there. All right. So if you typed in anything other than 0 or 100, then it would say what? An invalid score. So this is some ways that you can control your data, and they call that data integrity. Because many times when you are filling out an application, like when you even fill out something online, when you are trying to register for a website or do whatever, sometimes you might put in bad data. Like, now they can't really verify your data, like your name. They can't say, oh, that's not your name. Or they can't say that's not your address. They cannot say that's not your email. But they can kind of validate how the format of a name. They can validate the format of an address. They can validate the format of an email address, all right? Or they can validate the range of a certain number or age or whatever. So that, and they try to get the data to be as true as possible. So that's one big part of programming. Making sure you try to get data that is as true as possible, all right? Because you don't want they say the old saying for computer science is garbage in, garbage out, and what that means is if you collect data that's not correct, when you run reports, your data will be what? Incorrect. So, like I say, you try your best to control the user, so that they can input data that is valid, so that when you need to try to reuse it, it can work. All right, that data can be used for whatever purpose. All right, so now we compared numbers, right? Asking if numbers is greater than this, less than this, or greater than equal to whatever. We can do the same thing with character data. Because you remember when we talked about character data, I think it was in chapter 2. The letter A is actually stored as what? 65. Remember? So all the characters that's typed have character and have numeric values. And remember, we did that by doing what? The Ascii table. And I'm gonna go to a table if I can pull it up. All right. So we'll say we pull up this Ascii table here. All right. Now remember. Bless you. Remember the Ascii table, and we had, remember the letter A. Look, the char value of the letter A is 8, but the decimal value, which is the base 10 value, is what? 65. Remember? So all of the characters that any character you can type on your keyboard has a decimal value. So that's how you can check or test or compare values, character values. So it says relational operations can also be used to compare characters and string objects, okay? And it said earlier we learned to use relational operators to compare numeric values. They also can be used to compare characters and strings. All right. So if we look at this little table here, our character value 0 through 9. Now this is the character value because you see the little what? Single quote around it. Everybody understand that? This 0 would not equate to the number 0. Everybody understand? Let's look at this. So let's look at this. All right. So let's find the character 0. All right. The character 0 here is equal to what? 48. Everybody see that? But 0, we know itself, the decimal value for 0 is 0, right? See, it's 0. So you see what I'm saying? You cannot take these values here and equate them with the char values here, all right? The numeric value. So if we go back to the program, if I go back to the program and I do something like this, let me take this out. Let's say I'll take all of this out. I'll take all of this out up until here. Yeah, the functions don't matter. They can just sit down. All right. So I have the main function. And if I say something like char num is equal to 0, all right? Or I could say, I could say 9, all right? Then I could say int x is equal to, I'll say 0, all right? Now, I could, if I do a comparison, if I do, or if I even store the numeric 9 into another value, it won't give me 9. It's going to give me that ASCII value of 9, which is 57. All right. So if I do something like this, if I go back, I could say, let's say if, it might work. It should, if num is greater than x. All right. So all right. Else. That's another thing I noticed, y'all, when y'all writing y'all code, a lot of y'all don't indent your code. All right. So let's run this. It shouldn't ask me, it shouldn't give me an error, but it's going to try to compare the numeric value of one against the other. Nope, it did. Let's see. Oh, semicolon. Ah. But yeah, it's still, oh yeah, that's because X wasn't declared with the missing semicolon. Let me see if I got people no way. No. All right. So look at it this. So it says what? Num is greater than X. X is 0. Num is what? Really what? Num is really the 57. You got me? So we could even go back and we could change X just to what, 55 on that for the 55. We run it again, we still should get the same result. See, num is greater than X. But if we change this to it's 56, let's just make it 60. And then we run it, and all of a sudden now, I thought I ran it. You see what I'm saying? X is greater than num. So you got to remember this value here, if we compare it, it actually stored as a decimal value. So let's look at what we're talking about when we're talking about comparing variables, all right, or string or char values, all right. So we go back to the program. It says, notice, we'll look at A to Z. The lowercase, uppercase A and Z goes from 65 to 90. The lowercase A and Z goes from 97 to 122. So obviously, any lowercase alphabet is greater than any uppercase alphabet. All right, so keep that in mind. Blanks are 32. Periods, the value is 46. So let's look at the what they're saying here. They say, notice that every character, even a blank, has an ASCII code associated with it. Notice also that the ASCII code of a character representing a digit, such as 1 or 2, the ASCII value, is not the same value as the digit itself, which we kind of talked about and showed in the program just now. A complete table showing the ASCII values for all characters can be found in Appendix B, but we just went online and we just seen that. All right. So this is what happens when comparing two characters. Well, when two characters are compared, it is actually their ASCII value that are being compared. So when I'm comparing A against B, I'm really comparing what? 64 and 65. So when I say A, the character A less than B, I'm really saying is 65 less than 66. Okay? So because the ASCII value of A is 65 is less than the ASCII value of B, 66, and likewise the ASCII value of 1 is less than the ASCII value of 2, because the ASCII value of 1 is 49 and the ASCII value of 2 is 50. All right, so it works that way, but you got to understand it works that way because of the ASCII value. All right. So let's look at this table. But it says, however, shown in the table, lowercase letters have what? A higher value than the what? The uppercase value. All right. So it said what? The lowercase a would be greater than the lowercase no. So that what? Lowercase a is greater than lowercase or uppercase, my fault. Yeah, me confused. Uppercase Z. Right? Because all lowercase characters values have a higher value than uppercase value. So looking at this, a small program. Enter a digit or a number, all right? And we got the C in here. And it says if the value that you entered is what? Is greater than equal to the ASCII value, right, of 0 and the ASCII value of 9, which was those what? Those the number, right? Because if I put in what? It's asking me for a digit, right? Asking me for one digit, right? So if I put in 9, 9 is not actually equal to the ASCII value of 9. You got what I'm saying? But it's char, so it'll know that it's gonna compare char to char, so it'll fit within here. If I put in the letter A, the letter A will be compared with the letter A. If it's a T, the T gonna be compared, the value of A, which is 65, the value of Z, which is what it is in the table, it's 90, and T falls anywhere in between. So if there's anything in between, we know it's a character. Then what? The lowercase range is checking the ASCII value of the range lowercase a and lowercase z. Right? And if it's not if it's not a number, if it's not a uppercase, if it's not a lowercase, then it's not a letter or a digit. So this is just a small program just to check to see if a value that's in it is either a number or a alphabetic character. Okay, whether it's uppercase or lowercase. All right. So that's what this one did. That's basically what it did. And notice what? As long as they put one, they put T, okay, it's lowercase. Put a uppercase V, it's uppercase. They put the number 5, oh, it's a digit. Then they put a special character, ampersand. They fill out the range of any one of those three. So it was what? It was not a letter or a digit. Now, that's single characters, all right? You can always do that. But remember when you're comparing single characters and you want to compare the actual character, it has to be in what? Single quotes, not double quotes. Double quotes signify what? A string, all right? Now, sometimes the confusing part of that is I could have said up here, string CH. But if I would have said string CH here, what would I have had to do here? If CH is greater than or equal to what? Double quote 0, double quote. And CH less than double quote 9, double quote. So you see the difference? So if I would have declared it as a string, then I would have to put double quote. Because a string says what? I'm not dealing with a single character. I'm dealing with one or more characters. I could be dealing with one or more characters. So let's look at the string comparison. All right. So here it says that comparing string objects. Anybody in here? No. Okay. Comparing string objects. Okay. String objects can also be compared. Well, let's go back. In order for us to use string, we must first do what in our program? If we write in a program and we use a string, we need to go in here and say what? Pound, include, and what? String. We have to load our header file. Otherwise, you're going to get errors, okay? So make sure you remember that. You have to load the header file. So it says that string objects can be compared with relational operators. So we can compare if one name is greater than another name. And what? We can try to alphabetize information or put it in reverse order depending on our logic, okay? So as with individual characters, okay, when two string objects are compared, it is actually the ASCII value of the characters making up that string that are being compared. And what it does, it compares each character column by column. And when it finds a different character, whichever character has the higher ASCII value, that would be the one that's greater, all right? So it says, look at here, we got string str1 equals ABC. String str2 equal XYZ. Now, just looking at this, which one you think would be greater? All it's going to do is going to take the first one. Is A greater than Z? No. So this one would be higher. X. X would be, XYZ would be greater than ABC automatically because the first character was greater than the first character in the other. All right? So this string object str is considered less, string 1 or str1 is considered less than the string object str2 because the characters ABC alphabetically precede the characters X, Y, and Z, okay? So looking at this, so the following statement would be true. str1, which is ABC, is less than str2, which is X, Y, and Z, all right? So that would be true. Now, so let's look at a string that might have multiple characters that are the same, and then it finds something that is not, okay? So it says, one by one, each character in the first operand, all right, is compared with the character in the corresponding position in the second operand. All that's saying is, I have a string here with 4 characters, a string here with 4 characters. It's gonna try to compare the M in Mary with the M in Mark. Then it's gonna try to compare the A in Mary and the A in Mark. Then it's gonna try to compare the R in Mary and the R in Mark. And then it's gonna compare the Y in Mary and the K in Mark. And this is where your difference comes in. Y is greater, lowercase y is greater than what? Lowercase k. So therefore what? Mary would be greater than Mark. well, name 1 would be greater than name 2. Okay, so everybody understand that. So I'll write a little small program using that. So it says what? The value in name 1, which is Mary, is greater than the value in name 2, which is Mark, because the first 3 characters in name 1 have the same ASCII value as the first 3 characters in name 2. But now when you see the Y and the K, the Y in Mary would be greater than the K in Mark, which would make that string Mary greater than Mark. So name 1 greater than name 2? Yes, Mary is greater. Name 1 less than or equal to? That would be false because Mary is greater. It's not equal to and it's not less than. Name 1 not equal to name 2? That's true because what? This one has M-A-R-Y. This one has M-A-R-K. All right? So let's look back here. Now, look at this. Name 1 would be less than what? Mary Jane. Now you say, okay, why? Because now what? Name 1 is just Mary. Name 2, Mary Jane is M-A-R-Y, but then what? I have another comparison. Where this one, I don't have a comparison. So this is null, but this has a value. So this would automatically be greater than that, all right? Because it has an extra character. So let's go back to here. All right, we got string. So if we go into here, we say string name 1, and I could give it a value as equal to BRCC, all right, comma, name 2 is equal to I forgot my double quotes. Remember string values, double quotes, char values, single quotes. Now, looking at this, which one you think will be greater, all right? If I do this, and I'll say if name 1 is greater than name 2, then I'll put what I'll do it this way. I'll do it like this, and I'll say name 1, all right? And all right, so we'll do it like that. So else we want to output name 2, all right? All right, so we just gonna check. Well, that's wrong here. All right. All right, so what? I did an if in here. Well, I'll tell you, nobody saw that. So if name 1 is greater than name 2, we're gonna output name 1, then the is greater than, and then whatever name 2 is. Else, we're gonna output name 2 is greater than name 1. So what will output, class? It will output what? Lowercase letters are greater than uppercase letters, so what? The lowercase BRCC, which is name 2, is greater than the uppercase letters, which is name 1. So let's run it. What did I do? I didn't string. I didn't string. All right, so let's run it. Wait, what's going on? I didn't stream again. I even copied it wrong. All right, so that should do it. All right. So it should say, look, the lowercase BRCC is greater than uppercase BRCC. Now, all right, so even if I make them both the same, well, not say the same, I'll say BRCC and I put a space. What happens? This one has how many characters? 4. This one has 5. So even though the first 4 are identical, remember a space has a value of what? 32. So that would make this one greater than this one, right? So BRCC space will be greater than BRCC. Now, when we run it, you won't be able, you would probably wouldn't be able to see it unless I would put something at the end of it, something like say asterisk at the end, so you can actually see that that there's a blank space after. And I'll do. All right. So now when we run it, so let's run it. See, this one, the BRCC, notice it got an extra space here. It's greater than what? The BRCC without. All right. So I should have put this over here too. So because if I would do this, if I would take both of this on, this would show you. All right. Because it should be what? Back to back. But when I run it, watch, it's gonna give me that extra space. See, and I didn't put it in there. It should have been the name and then this. But see, it got that BRCC is greater than BRCC without a space. All right. So that's how comparing strings work. So you always can compare strings. You can compare numbers. Anybody with any questions? Any questions? All right. And notice what happened here. This is just a program where they ask if I think the string was equal to a certain thing. Because if the part number was a certain number, a certain string value, they multiplied by something. If it was the other part number, they multiplied by something else to get a value. So that's that's how computer science works. So let's do that. Let's do this. Let me say string. We just say string. We'll say. We'll just say call this string. Because let's say we use, we don't even put a value here. All right. And we'll just say, I'll say make. All right. We'll just say make. All right. So now, here what we can do an if or we do the case, but let's do the if. All right. And we'll do something like cout. All right, and then semicolon, and then what? CN. And now, if I wanted to get the entire make, I'll do what? Get it was what? Get dot get line CN comma make. If I could type. All right. So now I could get what? Spaces and whatever. Because what? I don't know if a make of that has two names, but still, you never know if a vehicle come out. Because when you write code, you always write code to just in case there's a situation that may come about. Like say, if I'm just writing it to input one name make, and then all of a sudden a new car make comes out. Now I have to go back and modify my code to match whatever. So if you write it to justify whatever could come about, then you won't never have to go back and try to remodify it. All right. So now here we could say once we're in a make, okay, and we could say if make is equal to, and then I'll say Ford. All right. All right. And then if it's Ford, we could just output something for that. Your just anything. Your vehicle has a low return. Whatever. It could be anything. Okay, we could say. And then let's say we say what? GMC, just anything. I have to do else if. I'll do else if. Else if make is equal to GMC, and I'll just do something like your has no return. I misspelled that return. All right. And I'm just making up something so that we can see what happens. All right. And then we could say what's another one? Okay, this will be else. I'll do 3. If make is equal to what? Honda. All right. And we'll say something like see how your vehicle has a high return. All right, so we have that. All right, so and then I can do this. I could say else and I'll do see out if I can say it. All right, and remember that's that validation part to make sure we enter in something valid. Okay. All right. Okay. So we have this. All right. So let's see. If make is this, else if this, else if that, else that. All right. Okay. So if it's forward, do this. All right. Else if. All right. So let's run it. Now, in a vehicle, say I entered, and even though I could put in FORD, all caps, what would happen here? This would be what? Invalid, because it's trying to compare the capital F, again, lowercase f, a lowercase r, capital F, lowercase o, a lowercase r, and a lowercase d. So this would be what? Invalid. So, and there's some things that you can do within C++ to what you could make everything uppercase or whatever you could do behind the scenes so that the programmer, the user wouldn't have to do some of this stuff, you know. But if I do that, look, invalid model enter, because remember we said it matched each individual character, right? And that means that what the forward all caps does not match a forward with capital F. So let's do that. This time we're gonna do capital F. All right. And look, your vehicle has a low return value. See here? And now let's run it again and let's check for another one. All right. Say we do GMC. And GMC is all caps. GMC. Now, it's going to check GMC against Ford. It won't. It's going to check the make, which is GMC against GMC. Then it's going to print what? You have no return value. See? Then if I run the other one for Honda, like I said, it got to be exactly like it is. Honda. All right. When I hit enter, see, your vehicle has a high return value. So see how you can take a string, all right, and compare it to another string, all right, or the string literal, all right? So you can write code to do that. Like say you can ask students to, a person to input their name, the first name. You might have to match it against a database list. If the name doesn't exist, well, Well, no, it's invalid. And sometimes that's how, well, most times, that's how password validations occur. A person will input their username. So you put in your username, like say with your bank, online banking, my website, the school, when you put in your L number, when you put in that value, then it goes to try to match it against all student records. If it's the bank, all bank accounts that they have. So it try to match it. If it does not find that match, that's when it say what? Oh, it's not found, right? So that's somewhat what we're doing here. So you're doing little by little of what some stuff for what you're actually practicing as a user already, all right? So once it finds a valid, and you can write a program different ways. Most people write a program, you have to type in a valid ID before you type in a password. That's some form of protection, because what? You don't want a person to try to type an ID and a password at the same time and then say, oh, the ID worked, but the password is wrong. You're giving a criminal too much information, right? So it all depends on how you write it. And some people might write code to where what? You try attempts. You try so many attempts against the software, and that's going to be in our next chapter. So many attempts to input the right login. After so many attempts, what? It locks it out. So now it has a what? A counter to count how many times you went through those series of statements. And once it says, okay, you've exceeded your attempts, we're going to lock you. You need to either call this number or click here to reset a password. So the stuff you're doing, class, it might seem minimal, but it's understand, and these are some of the techniques that are used to write code, all right, when you're going to start writing code, all right, like say for companies. So that's how you compare character data, all right? And we did the little program where we compared a car make. They did it where they compared a model of a product, okay? Any questions? Questions? Now, look at this. This is a small different way of writing a if condition, all right? It works, all right? But like I say, it's all in user preference. If you had a situation where you know you wanted to compare something, and if it's not this, I want to give a value to this variable, and if not, give a value to this variable. Or it could be the same variable. If it's this, give y is equal to 10, else y is equal to something else. But what they did, they just used 3 different variables in here. What this says is, and like I said, you could read through it, but we'll go over it. What this says is, this is a valid C++ statement. This reads as, if x is less than 0, and if it's true, there's a question mark, if it's true, assign 10 to y. If it's false, if x is not less than 0, if it's false, assign z to equal 20. That's all it's saying, all right? So if we go back here, same thing. So we could say, if we use x is 60, right? So we take all this out, all right? So we could say what? And we'll give 2 other variables, I'll say, and we'll do y and z, all right? So we could do something like, all right, my fault, x less than 100, all right, question mark, y equals 10, all right, colon, z equals negative 1,000. Simple as that. Now, when I output, I could do what? I could do cout. Let me set to a value so that equals 0, z equals 0. So now what happens? If x is less than 1,000, less than 100, it's going to assign 10 to y and let z stay to be 0, because what? It won't do that. If x was greater than 100, then it would leave y as 0, and then it would change z to a negative 1,000. All right? So we're going to see out x, and do this. And so save time. All right, so let's run it. We run it. And what me make? Oh yeah, because I didn't take that statement out. But look, x is 60, y is 10. All right, because what? 60 is less than 100, so it did this part. Y is equal to 10. But what? Remember, we initialized z to 0, so it never did anything to z. So it's a simple way of doing an if statement, and you can assign values to those variables. All right, so I'll take this out again. And now let's make x 160. So 160 would be greater than 100, right? So if we run it this time, yeah. So you see, you keep, I hate that. I'm gonna just run it. I'd like you to be able to see it. All right. So we run it, and look, x is equal to 160, which 160 is greater than 100. So that now we're gonna do the false side. So y remain what? 0, but z is now equal to what? A negative 1,000. So see, it's just a simple if logic. You can choose to write it this way. You might not ever want to use it, but it's a way you can write code also. All right? All right, any questions? All right, so that's just a simple way of writing it. And look, if you wanted to write it in the regular if format, look, if x is less than 0, that's this part. The question mark, you do this for true, all right? Else, the colon, you do this for false. So basically the same thing, but just a different way of doing it. And which one is right or wrong? Neither right or wrong, it's just a different way of coding, all right? And it's just showing you what happens. First expression is the condition or the test. The second one is if it's true, this is what we're doing. And the third one is what we're doing if it's false. Simple as that. Simple as that. Now, what they're saying is if you feel confused with all the symbols or whatever, you can put parentheses around it to group it, and which doesn't change the fact that you're asking if this is less than this, do this, then do that. So there's no issue. All right? All right. So, like I say, you could always do that. All right? And look here. What happens here is now the same particular expression here, but what they're doing, they're actually assigning the values for the true to this variable or the false to this variable. Same pretty much thing. So this says A gonna equal to 0 if this is true, and it's gonna equal to 1 if this is false. So A is equal to x greater than 100. If that is true, it's gonna assign 0 to A. Otherwise, it's gonna assign 1 to A. That's all that's saying. And look, rewritten, if x greater than 100, A is equal to 0, else A is equal to 1. So see, same code, same results. It's just a different way of coding. So a lot of times when you go online and you see code and you're like, man, why did they do this? What is this? It's just a different way. It's just a different way of coding. It's not that it's right or wrong, it's just different. All right? All right. And I think in this program, or did they? Did they use that in I'm not sure. Let's see. No, Yeah, yeah, they should have used the concept of the charges, not the charges. I don't see it. Yeah, look here. So it say hours equal, right? If hours is less than minimum hours, okay, then you're going to assign minimum hours to hours. Otherwise, you're going to assign hours to hours, whatever hours was equal to. What this program did is, like many times when you go to a consulting agency or whatever, or a lawyer, they have a minimum fee, all right, or a minimum rate for or a minimum hours. And this what this program is doing. So what happens is, if this company says, okay, when I see a client, I'm going to have a minimum charge of 5 hours, okay? No matter what, 5 hours. If you meet them for 1 hour, that's 5 hours. If you meet them for 10 hours, it's going to be 10 hours. But anything less than 5 hours, you're going to still charge them 5. Because look right here. And this is what it says it. If hours, say hours could be 3, all right? 3 is equal to, if 3 is less than 5, assign 5 to hours. So now hours will be 5. But if hours was 10, 10 is equal to, if 10 is less than 5, no, it's not. So it's going to skip this one and it's going to assign 10 to hours. So that's a little thing you could kind of use. Like I said, if you're writing code for an individual and they have a minimum limit of something, bam, you got the little smidge of the code that you could just throw in there. Might have to change your variable name so that you understand what it is for that company, but you got it right there. So like I say, don't be afraid to look at code and see stuff that works and not use it. What happens with computer science students, and we do it most times, we try to reinvent the wheel, all right? Many times you have modules or parts, segments, or smidgets of code that's already written that performs a particular task, and what we try to do is try to rewrite it. If it works and it's efficient, we could use it. We don't have to say, well, let me try to rewrite it. Now, if you want to learn it, cool. I don't have any issues with that. But many times when you're on a job, all you're trying to do is get a program to run. You might be on a time schedule. And what? You're not worried about trying to learn how to, but I know where I can get the code that I need. But then many times you have to modify it, like I said, with the variable names and whatever passing variables or whatnot to make it fit with your program. But don't be afraid to use code that you know that will work. That sometimes saves you a whole lot of time. All right. So, but that's how that program actually works. It actually gives a minimum, and then if it goes beyond that, it's gonna give them the max. All right. So here we got this here. You can even use the string. Okay. See out. Your grade is, all right. And what happens is, if score is less than 60, you're gonna print fail. Otherwise, you're gonna print pass. So this statement, in a sense, is saying, and like I say, given a test, if you made less than 60 on a test, you're going to receive a output of fail. All right. If you made 60 or above, you'll get a passing grade. All right. Now, that's just like saying many times you have standardized tests. You could use this statement so that when a person completes a standardized test, if the standardized minimum is, say, 75, then what we'd have to change in here? If score is less than what? 75, right? So once you take that standardized test and it compares that score, and that score is less than 75, it's going to print fail. If you make 75 or better, it'll print pass, and you pass the standardized portion of the test, or whatever test it is you took. All right, so that's all that's doing. And look, if logic, same thing. All right, so any questions on this section? All right. Then, like I said, this is different ways of coding, but you need to learn, need to know. Don't think, how would I say, inside the box. Think outside the box. There's many different ways of coding, and there's no. And like I say, if it works, it works. You know, don't be afraid. Now, the switch statement. We went over the switch statement already, but we can kind of look at this and see what the book is actually saying. But we kind of went over it with the switch statement. What happens is you have switch and then the variable that you're trying to match, all right? And then you do case and then the actual value that you're matching. And if whatever you're matching, you have all your statements. Now, you can break, but you don't have to break on a switch. And we'll look at that. I can show you that after that. But what happens is if you don't break, it's going to automatically perform all of the statements in the following cases until it finds what? A break. Okay? So that's the difference. Sometimes you want that, sometimes you don't. And let's look at that in a little while. Let's see. All right, let's look at this situation. Here it asking you to enter A, B, or C, right? So you're seeing a value, the choice, all right? A, B, or C. If it's A, it's going out, you enter A. If it's B, you enter B. If it's C, you enter C. But if it's not A, B, or C, it's going to default and says you did not enter A, B, or C. But notice between each one, they have the what? Command what? Break, right? Everybody see that? The break command, once the system see the break, it says, okay, break out of all of this and continue with your program. Now, all right, so that's one way, all right? And all it's saying here, case, it matching the A. If it matches, it do this, then it breaks, all right? It matches, if it found this, it do that, and then breaks, all right? So the case statement shows the program where to start execution. But class time. I said a long this time for the end of class, but we can continue for a little while. I'm gonna go over the break. All right. Now notice here. Well, let's look back at here. Notice you got the break. You break. So if it check for A, it doesn't find it. Go check for B, it doesn't find it. And check for C, it finds it, and then it breaks. All right. But look here. In this example, you don't have any breaks. Exact same code minus what? The breaks. All right. What happens here? Now, what happens here is if I input the letter C, a capital C, it'll check this, nope. Check this, nope. Check this, yes. It print this, and then it exits. All right. No, then it prints default because it didn't find a break. So it's gonna print this and this. I enter the letter A. It's gonna output. You enter the A. It's gonna output. You enter the B. It's gonna output. You enter the C. It's gonna output. You enter the D, and then it exits because it never found a what? A break. All right. So if I go back here and I take this. No, I don't put this logic. I'll do this number here. Oh, let's see. Do that number. All right. Or something. What we had? We had a value. We had a value. Well, we got num1. Let's say num1 equals say 80. All right. So if I did something like this, say switch, and I'll say num1. All right. So num1, I declared it to be 80. All right. But then when you have a switch, you always have a body. Your switch has a body, open and close curly braces. Then I'll do case, and I'll say 90. All right. And then the colon, and whatever I want to do, however many statements I want to have in here, I can put them. Okay. I could do a C out, just something like let's see, let's do the letters. I'll do a letter rather than an exact score. I'll do sure num1, And I'll say equals A. All right. Equals A. So now, all right, so now we do case number one, it's still number one. And if it's an A, all right, I'll say you earn an A. All right. All right. And then I have to put the what? Break. All right. And like I say, all lowercase for C++ statement. Right? I mean command. Then I'll say case B and then see out. All right. All right. So now, what did I do? Something that should. All right. So now, I'll do one more so we can actually see what's going on. And then I need what? Break. All right. I got to put break in here. And then the last one I'll do case C, and I got to put that in single quotes. Because if not, I'm dealing with the variable, not the ASCII value of A or B or whatever. All right. So now, case C, and then see out. You earn. Okay. All right. So now, and then the default. All right. All right. So now we have this information and we got our close. Now, based on this, when I run it, it's gonna go through this and check it. And what happens is going, do I have to put in, yeah, I gotta put in a value. Or did I? Well, I got capital C out. Wow. And did I allow, oh, I made it A. I'll tell you what. I'll leave it as A because I'm gonna show you. What, I got an M. How y'all let me type this and don't say one word? All right. I need to clean my glasses. What do I do here? Inline, inline, inline. All right. Okay. Nope. Oh, that's total. What happened there? That shouldn't even be registered. Let's run this. All right. Okay. So remember, it did that because what? A was already initialized. I didn't input the value. But check this out. Watch what happens when I take the breakout. All right. I'm gonna comment it out. I'll take this breakout. What should happen? It should say you've earned an A. Then what? It didn't see a break, so it's gonna automatically perform the next one. It's gonna say you've earned a B, and then it's gonna see a break, and it's gonna kick out. So it's gonna say you've earned the A, you've earned the B, and kick out. You understand? Because it did not see that break. All right. Now, if I took out this break, okay, now you're gonna get, you've earned, once it finds a valid case, it's gonna start executing until it hit a break. So and I don't even have a break here, so I'm gonna put the break here. I forgot to put it. The first time. So it's going to print out, you've earned the A, you've earned the B, you've earned the C, and then it's going to break out. So when I run it, you see what I'm saying? So that's somewhat confusing. So if I comment this one out, all right, and what's going to happen now, it's going to just print all of it, you know? And when I run it, you know, it's going to be very confusing. You see? So it printed out all of it. So you write your code and you forget the break in it, you'll be very, confused if you're saying, well, man, it's a B or it's an A and it's doing this. When I do a B, it's doing this. So you got to be aware. Now, check this out though. If I do this, I might intentionally want to eliminate a break. All right. You say, well, Mr. Sylvester, why would that be? Or why could that be? All right. In the notes, it tells us that sometimes, like say, if we checking for an uppercase and lowercase a, right? I could do the case uppercase and then case lowercase. Now, so what? Being that I have a case for uppercase and no break, it's going to what? It's going to still perform this, but then it'll break out. You got me? So sometimes you're trying to, you want to check for multiple cases and don't want to break out because you want it to do the same thing for those values. All right? So if it's an uppercase A or lowercase a, I don't want to kick out on just the first find of anyone. If it's find the uppercase A, fine. Okay, but if not, check for the lowercase and then it outputs whatever. Or what? If it check for the lowercase and it finds it, I'm gonna output this. All right, so watch when I run it. All right, it's uppercase A. See, it print that and it kicked out. Right, but then I could change this to lowercase a, and then we're gonna go lowercase a. If I can type. Lowercase a, now it should do the what? Exact same thing. See? So sometimes, just sometimes, you may want to have a case without a break because I'm checking for multiple things for it to match and then give me the results for that particular value. All right? Any questions? All right? And basically, toward the end of the chapter, we used the switch in the menu. I showed you how to create the menu. And look, this is where they created their menu. And then from that menu, you have your switch, your choice, and then case whatever, and you can do whatever, break. Do whatever, break. All right? And basically, this is the end of the chapter because, this deal with block variables. What happened with block variables, you got to be very careful. Because variables that's in a block, let's go to here. What happens when you have blocked information? I don't know if I had a program with block values. Let's see. No, switch. Nested, no loop. I think I had some with a loop, but I'm oh yeah, we're not on loops yet though. So let's go back. Let's just go back to the program, create a new one. And it's C++. And I'll show you what I'm talking about when they talk about blocks. Many times, what happens many times, you might have something like int x equals 0. All right. Now, I'll say 5. X equals 5. And then you might have something like for int x equals 0, x less than 10, or let's say x than 3, x plus plus. Did that wrong. And that's a loop. Don't worry about the loop, but okay, this will be here. But what happens here is now I have a different body. Outside of here, X is what? In the main, X is known as what? As being equal to what? 5, correct? But in here, I got a different scope because what? I got a for loop and this is the scope. So I have an X that's out here in the outer scope, but then now I have an X here in the inner scope. So what happens is now I can do what? See out, and I'll just say /t and X in, I'll just say inner loop. All right. All right. And I'll print out X. Now in this loop, X is gonna go from 0 to 2 because they say less than 3. It's gonna go 0, 1, and then 3 it kicks out. All right. Or 2, and then 3 it kicks out. Now, so it's gonna output 0, 1, 2. And then what I'm gonna do is, I'm gonna put it back. Then what I'm gonna do, I'm gonna output X again. All right. So now I'm gonna do C out, or I can do the same thing here. I'm gonna copy this. All right, and change this to outer. If I can type. All right, outer loop. Now, let's run this program. What you think's gonna happen? We're gonna print out the inner loop and it should print, X is equal to 5. It falls in here, X start at 0, 0, 1, 2. It kicks out the loop. Now I'm back in the outer loop and X should be what? 5 again. So let's run this. Oh, what did I do? What did I do here? What's going on here? Power include function. Let's see what happened. See out. Oh, y'all, I tell you, NL. All right. All right, so now, watch what happens. Look here, X inner loop, 0. X inner loop, 1. X inner loop, 2. X outer loop, 5. So what? It assigned 5, but I didn't print it out, but I did this loop, and it performed this 3 times, and it went from 0, 1 to 0, 1, and 2. All right, that's 3 times. And then once it got out of the loop, it remembered what? Now I'm in this scope, and X is what? 5. So you got to be mindful of the scope of the variable. And you can have a variable initialized twice if it's in a different scope, right? So that can be done, but sometimes you want to guard against that because you have, number one, you got to keep track of it. And number two, sometimes you might get confused and you're trying to get a value and that value is being changed and you don't know what loop, what scope you're in. So you got the local scope, all right, and then you or the block scope. So when we look at this, X at this time is local to what? The for loop, all right? That's its scope. Once we get out of here, X is still what? In this scope, all right? So you got to be mindful of that, all right? So like I say, you got to watch. So look, I think in this program, you got what? It's CN income, all right? So we inputted income. This is just a, I think, straightforward program. And then we asking if income is greater than whatever, and we're doing whatever. But notice what happened. They inputting year rather than initialize year when they or not initialize. Rather than declare year when they declared income, they made year in the scope of what? Of that if statement, all right? So they introduced that year when they actually used it. That's a good way to program, but sometimes you get lost trying to find your variables. All right. But like I said, it's up to you as to try to figure out how to. All right. But if you look at it, year is saying int year. Year scope is in here. This is the only place you can use year. If you try to output the value of year, once you leave out of here, out of the scope, like outside of here, you're gonna get an error. All right. So that's it. So like I say, same variable name, that's what we're talking about. All right. So class, what I'm gonna do, I'm gonna post a test, and you can take it from now until the next class period, okay? And like I say, study. You still have your 2 opportunities to take it. Test center is closed. You better take it from home. I think I got it set up where the responders. So you gotta you take it and it's gonna have you in that lockdown browser. All right. So on next class period, we start on chapter 5, which is loops. So try to take your test. I think I post the assignments already, and if not, I'll post the assignments, and then you'll also have your test to take. All right. So I'll see y'all on next Monday. Okay. All right. Any questions? Anybody with any questions?